Hi everyone! Today we'll be taking a look at side-side-side similarity. Here's today's FLT. Given two triangles, I will be able to tell whether or not they are similar using the SSS, so side-side-side similarity theorem. Last time we talked about angle-angle similarity, and today we'll be talking about side-side-side similarity. So the side-side-side similarity theorem states the following. If the three sides of one triangle are proportional to the three corresponding sides of another triangle, then the two triangles are similar. So what do I mean by this? Here I have triangles ABC and DEF, and all the corresponding sides are color-coded. So for example, AB and DE are corresponding sides. Notice how I've written out the ratios of the corresponding sides. Basically, think of these as the scale factors. So the first ratio is DE over AB. I usually like to just do the second triangle over the first triangle, but it's okay if you do the other way. Another ratio of corresponding sides is EF over BC, and the last one is FD over CA. So if all of these ratios, or the scale factors, are equal to each other, then we have enough information to say that triangle ABC is similar to triangle DEF. So in order to use the side-side-side similarity theorem, we need to make sure that all three ratios of corresponding sides are equal to each other. So basically what this is saying is, for example, if the side length going from AB to DE is doubling, all the other corresponding sides must be doubling in length as well. For these examples, we'll be determining whether or not the triangles are similar by using the SSS similarity theorem. So here I have triangles ABC and PQR, and we're given side lengths. Remember to draw these as accurately as possible in your notebook. And we're going to figure out the ratios of each pair of corresponding sides. So the first pair of corresponding sides are the sides AB and PQ. I just like putting the second triangle first, so PQ over AB is going to be 6 over 2, which simplifies to 3. Next pair, side BC and side QR. This is another pair of corresponding sides, so we're going to find its ratio or its scale factor. QR over BC is 18 over 6, which simplifies to 3. And we have one more pair, sides CA and RP are corresponding sides. So RP over CA equals 21 over 7, which also simplifies to 3. So because all three ratios of the corresponding sides are the same, we can say that the two triangles are similar to each other. So triangle ABC is similar to triangle PQR by side-side-side similarity. Basically, what we're doing is finding scale factors of all three pairs of corresponding sides and checking to see whether they're equal or not. If they're all equal to each other, then we can say that the triangles are similar through SSS similarity. Here's another example. Are these triangles similar to each other? We have triangles DEF and XYZ. So let's look at our first pair of corresponding sides. Side DE corresponds to side XY. So XY over DE equals 7 over 14, which simplifies to 1/2. And if you're unsure about how we simplified that part, please let me know. Up next, we have another pair, side EF and side YZ. So let's find the ratio, YZ over EF. That's 9 over 16, which is not equal to 1/2. So here, the triangles are not similar because the sides aren't exactly proportional to each other. The ratios of corresponding sides aren't equal. Notice how we didn't even check for the third pair of corresponding sides. Once you see that two ratios are not equal to each other, that's enough information to tell us that the triangles are not similar. Let's look at one more example for this topic. So are these two triangles similar? Notice how the second triangle is not facing the same direction as the first triangle. So how can I easily identify pairs of corresponding sides? Well, you look at each side length. The shortest side length of the first triangle will correspond to the shortest side length of the second triangle. And the longest side lengths will correspond to each other as well. So whenever you see triangles that aren't facing the same direction, just take a look at the side lengths. Our first pair of corresponding sides is side WU and side KM. These are the shortest sides of each triangle, so they correspond to each other. So let's write out our ratio. Side KM over side WU, which is really hard to say, by the way. So we have 143 over 22. If we plug this in our calculator, we get 6.5. So you don't have to leave the ratio as a fraction. If it's easier, you can definitely convert it into a decimal. We have another pair of corresponding sides, sides WV and KL. Notice how these are the medium sides of each triangle. So let's find the ratio. KL over WV is 156 over 24. This also equals 6.5, so it seems like we're on a good track. Let's check the last pair of corresponding sides, side VU and side LM. So let's set up our ratio, side LM over side VU. This is 182 over 28. And if you plug this into your calculator, you will find that this ratio also equals 6.5. So all three ratios are the same, which means that the three sides of the smaller triangle are proportional to the three sides of the larger triangle. So triangle WVU is similar to triangle KLM by the SSS similarity theorem. When you write these triangles out, make sure they correctly correspond to each other. And I mentioned this earlier, but for setting up the ratios, I tend to put the second triangle side over the first triangle side, but you can definitely do something, for example, like WV over KL instead. But in that case, make sure that all the other ratios are also set up that way. So as long as it's all the second triangle over the first triangle, or all the first triangle over the second triangle, you're good. Let's quickly take a look at how we'd set up a two-column proof for this example. So let's say this example actually asked us to prove that the two triangles are similar. Then, for one of your statements, you would simply put the following. So side KM over WU equals side KL over WV equals side LM over VU. And this is given to us based on the diagram. And this statement basically just tells us that all three ratios of corresponding sides are equal to each other. And this is actually enough information to tell us that triangle WVU is similar to triangle KLM. And for the reason, we would put the side-side-side similarity. So SSS similarity tells us that the two triangles are similar. So here's a quick review for today. The side-side similarity theorem states the following. If the three sides of one triangle are proportional to the three corresponding sides of another triangle, then the two triangles are similar. Today we use this theorem to tell whether triangles are similar or not. Great job, and please remember to submit your notes on Canvas.